Hi everyone, welcome to part 3 of lecture 11. And in this lecture, we will discover the Eve's law. It is similar to the Adam's law, but in this part, we will discover how we can calculate the variance of x by using some conditional things, okay? So the Eve's law tell us we can calculate the variance of x by using the expected value of variance of x given y plus the variance of expected value of x given y. So in the first term, we will get the expected value of conditional variance of x. In the second term, we will get the variance of conditional expected value of x. So you don't need to memorize these formulations. If you need in exam or quiz, etc., I will give you. Or if you need something outside the class, you can look at the sources. But just to make it more clear, I will give you the proof of these formulations. So first look at the first term here, the expected value of variance of x given y. And focus on how we can calculate the variance of x given y. The first things we need to do, the calculating the second moment of x, right? Which is simply like, remember the variance of x, which is equal to expected value of x squared minus the expected value of x squared. Okay. So instead of unconditional one, we will use the conditional one. So I can write this guy, the variance of x given y, as the expected value of x squared, the second moment given y, minus the expected value of x given y squared. Okay. So as you know, the expected operation is the linear. So I can write this guy as the expected value of x squared y minus the expected value of x given y squared. Okay. And we know that this guy, which is equal to expected value of x squared, right? Expected value of conditional expected value is the unconditional expected value. So you can check from here. Okay. So this is the expected value of x squared minus the expected value of x given y squared. So that is the first term. And let's look at the second term, which is the variance of expected value of x given y. Again, we can calculate the variance of x based on this formulation, the second moment minus the expected value of x squared. But now again, we will use the conditional situations. Assume that this is a random variable like k. So to calculate the variance of k, what I can do, the expected value of the k squared minus the expected value of k squared. Okay. And instead of k, I will just write the expected value of x given y. So it will give me this this subtraction, the expected value of x given y squared minus the expected value of x given y squared. Okay. So what is this guy? Same as here. Sorry, same as here, which is equal to expected value of x. The expected value of conditional expected value of x is equal to unconditional expected value of x. So that's why, which is the expected value of x squared. So what was the formulation? This one. So instead of this guy, I can write that this one. Okay. And instead of this one, I can write that this one. Okay. So when I write that one, these two guys will cancel each other, and I will left with expected value of x squared minus the expected value of x squared. Okay, so what is that? That is equal to the variance of x. So that is the proof of the Eve's law. In summary, I can use, So in summary, I can use the conditional things to calculate the variance of x by using the Eve's law, okay? And to make it more concrete, is you just revisit the minor example. And let's say, first, let's write down the calculated informations. Remember that, where is it? Here we found that the expected value of x is 10. We found that one, right? And where is it? Okay, so for this one, the expected value of x given y, I can write 2, 13, and 15, right? Because I have already calculated the expected value, which is 10. So I can just put that value into the summation. So that will give me the expected value of x given y, and that can be considered as a new random variable, can take 3 different values, 2, 13, and 15, with the equal probabilities, which is 1/3, okay? And other things, we can look at the conditional variance, which is first one, the variance of x given y is equal to 1. Remember that the meaning of y is equal to 1, choosing the first door, and the person, the miner, will escape from the mine in 2 hours, right? So there will not be any the variation, just they will escape. So that's why that is the variance of 2, right? That is the variance of 2. If he choose the y2, if he choose the second door, that means the y will be 2. The variance will be the variance of x plus 3, right? Because if he choose the second door, he will spend 3 hours and he will come back where he started. And again, there will be another x because he needs to choose another door. So that's mean we will have another x values. So that's why I have to calculate the expected, the variance of x plus 3. And for the last one, I have to calculate the variance of x plus 5. Because remember, in the third door, he will spend 5 hours. So the variance of 2 is 0, right? And because that's the constant value, and it will be 0. And variance of x plus 3 and x plus 5 will be equal to variance of x, because that adding the constant values will not affect variance, variance of the random variable. That's why I can rewrite this part as the variance of x given y, and that can be considered as a new random variable, which can take 2 different values. That can be 0 with the probability of 1/3, and it can take the variance of x with the probability of 2/3. Why? Because both of them is the variance of x, and the probabilities is 1/3 and 1/3. So the summation is 2/3. Okay. Okay, let's first calculate the expected value of variance of x given y, which is the first term of the Eve's law. It is easy. 0 times 1/3 times plus variance of x times 2/3, right? Which is just the generic way of the calculation, calculating the expected value of a random variable. So you can think this is a random variable. And that will be 2/3 times variance of x. And the second term is the variance of expected value of x given y. So again, that can be considered as a random variable. And remember, we can calculate the variance of x as the expected value of x squared minus the expected value of x squared. Instead of x, I will use that one. Okay, I will consider the expected value of x given y as x here, so as a random variable. And I know that this guy can take 3 different values, 2, 13, and 15, with the respective probabilities. And to calculate this one is easy, which is 1/3 times 2 squared plus 1 over 3. 1 over 2, these are the probabilities, and 2, 13, and 15, the values this guy can take. We know that from here. And I just need to take the square of them to calculate the expected value of x squared. And the last term will be 1 over 3 times 15 squared minus expected value of x squared. And we just calculated in the previous part the expected value of x, which is 10. And the results will be 98 over 3. So which is the variance of expected value of x given y, right? So what the Eve's law tell us, we can calculate the variance of x as this guy minus this guy, right? Let me, sorry, not minus, plus this guy plus this guy. So which is 2 over 3 times variance of x plus 98 over 3, which is equal to the variance of x based on Eve's law. And that will give me the variance of x is equal to 98. So that is how we can use the Eve's law to calculate the variance by using the conditional variance and the conditional expected value. Okay, so I hope that's clear. And in sometimes using these formulations to calculate the unconditional variance will be much more easier than the traditional way. Okay, so that is the end of part 3, and I will see you in next part.